Right, well, we've been finding lots of zeros for polynomial functions. Let's see. Well, what are we going to do here? Write each function as a product of linear x minus c in that form and irreducible quadratic factors. Now, what do we mean by irreducible quadratic factors? It means it's irreducible over the reals. I'm not sure that makes a lot of sense. But basically what you got is you got something that's like an x squared quadratic, x squared plus a number. But when you solve that, you're going to be solving to an imaginary number. It's where the real coefficients, they have real coefficients, but no real zeros is going to be associated with that factor. Then we're going to write it as the product of linear factors, and then we're going to list all of the zeros. Now, here's what I'm going to do first. I'm going to work on the last part, listing all the zeros first, and then we will write them as products of linear and irreducible quadratic factors, and then the product of linear factors. So here we got x to the fourth plus x cubed minus 26x squared plus 4x minus 120. And you can see here that I have graphed this, and I can see that there are two real zeros in this. Now, there's 4 zeros. They could all be real. I might not just have my window large enough to see it, because I have it in standard form or default mode, negative 10, 10. Or we could have some imaginary zeros. I don't know. But let's see. Let's start with 1, 2, 3, 4, 5, 6. How about negative 6? And I'm going to use synthetic division. I should get a 0 remainder. Right, I'm writing the coefficients. Let's see what happens here. Let's bring down to 1. So negative 6 times 1 is what? Negative 6. 1 minus 6 is negative 5. Negative 6 times, make a better 6 right there. Negative 6 times negative 5 is positive 30. Negative 26 plus 30 is 4. Negative 6 times 4 is 24, negative 24. 4 minus negative 24, or 4 negative 24 is negative 20. And negative 6 times negative 20 is positive 120. Thank goodness I got a 0 remainder. All right, now I'm going to take this depressed polynomial, which would be x cubed minus 5x squared plus 4x minus 20, and I'm going to synthetically divide it by this second real 0 that I see, which is 1, 2, 3, 4, 5, positive 5. I'm going to bring down the 1. All right, 5 times 1 is 5. Negative 5 plus 5, of course, is 0. 5 times 0 is 0. And 4 plus 0 is 4. And 5 times 4 is positive 20, and shazam, we got another 0 remainder. So we've proved with synthetic division that one of our zeros is negative 6. One of our zeros is 5. And then I've got this depressed polynomial, which is going to be x squared plus 4. And that is an irreducible quadratic factor. But we're going to keep on going. So let's head to the next slide so we got a little room to work. All right, so if I got that irreducible quadratic factor, which was x squared plus 4, we're going to set that equal to 0. So now we got x squared equals negative 4. We're going to take the square root of both sides, so that x is equal to plus or minus the square root of negative 4. And of course, the negative gives us the square root of a negative 1 is I, and the square root of 4 is 2. So x equals plus or minus 2i. Okay? So what were our zeros then? we had -6, 5, and then plus or minus 2i. Now, remember when we're writing these as linear factors, our zeros then take the form of x minus c. Let's do the a part first, where we write them as linear factors and irreducible over the reals. So if I plug in this -6 to x minus c and substitute -6 for c, then I've got a factor of x plus 6. I substitute in 5 for c and x minus c, and then I've got a linear factor of x minus 5. And then our irreducible over the reals was x squared plus 4. So this is the a part of that, writing the linear factors and the irreducible over the irreducible quadratic factors. And then for the product of the linear factors, again, I've got x plus 6, x minus 5, and then we've got x plus 2i, and then x minus 2i. Shazam. Now, you can probably see why I went to find the zeros first. Then all I've got to really remember is just writing this, thinking about this, x minus c, which is really going to change the signs of my real zeros. Shall we do one more? Of course. All right, this time I got x to the 5th. That's my leading term, so I know I got 5 zeros of some type, either real, imaginary, whatever. Minus 2x to the 4th, minus 2x cubed, minus 6x squared, minus 99x plus 108. And I'm looking, I think I've got real zeros at -3, 1, and 4. So let's first synthetically divide using -3. And I'm writing my coefficients down. 1, -2, -2, -6, -99, and then positive 108. And let's bring down the 1. All right, -3 times 1 is -3. -2 -3 is -5. -3 times -5 is positive 15. -2 plus 15 is 13. -3 times 13 is -39. -6 -39 is -45. Let's see. I think -3 -45 is 135, but I might better make sure, not rely on my 3 times 45. -3 times -45, yes, 135. 135. So I got -99 plus 135. And so that's going to be 36. Now let's see, what's -3 times 36? I hope it's -108. -3 times 36. Shazam, it is -108. 0 remainder. All right, so we proved -3 is one of our zeros. All right, I'm going to take this depressed polynomial, and I'm going to synthetically divide by the second zero I see there, which is 1. I didn't give myself much room. Let's bring down to 1. All right, let's see, 1 times 1 is 1. -5 plus 1 is -4. 1 times -4 is -4. 13 times -13 -4 is what? 9. 1 times 9 is 9. -45 plus 9 is -36. And 1 times -36, -36, and shazam, we got another zero remainder. Let me jot down that depressed polynomial. 1, -4, 9, -36, because we're going to divide it synthetically by 4. All right, so I got 4 in the box. And then my depressed polynomial, since I ran out of room, is 1, -4, 9, -36. We're going to bring down the 1. All right, 4 times 1 is 4. -4, +4 is 0. 4 times 0 is 0. 9 plus 0 is 9. 4 times 9 is 36. And shazam, we got another 0 remainder. So let's see. We had a 0 at what? -3. And 1 and 4. And now I've got a irreducible quadratic factor, which is x squared plus 9. I'm going to set that equal to 0. It's going to be an imaginary number. So x squared equals -9. Taking the square root of both of those, x is equal to plus or minus the square root of -9. So -1 is I, square root of 9 is 3, and so x is equal to plus or minus 3i. And so there's my other two zeros, which makes 5. 1, 2, 3, 4, 5. All right, let's write these as linear factors. Remember, as a linear factor, I'm writing it in this form. We're going to write them as linear factors and irreducible quadratics. And so I've got x minus -3, or x plus 3, x minus 1, substituting in 1 for c, and then x minus 4. And then my quadratic, irreducible quadratic factor, which was x squared plus 9. All right, and then we're going to write them as the product of linear factors, which again, the first 3 are going to be the same. X plus 3, x minus 1, x plus 4, and then x plus 3i, and then lastly x minus 3i. And shazam, we have done it. We've been finding the zeros, baby.